This is a demonstration on how to use the Easylaser shaft alignment system utilizing the Easyturn program. The Easyturn program is a feature of the D480, the D505, and the D525 systems. We begin by mounting the shaft brackets. Simply hang the chain from the bracket, then pass the chain under the shaft and hook it onto the pin. Now we mount the riser rods. There are many combinations of rod length because they can screw into each other, so choose a size that will allow the laser beams to pass over the coupling comfortably. Make sure all the rods are tight. Next we mount the measuring units. One unit is labeled with an S and is mounted on the stationary machine. The other is labeled M and is mounted on the movable machine. Each unit has a detector and a laser beam. Roughly level both units using the spirit levels, then make sure that they are tight. Next we attach the cables. You connect one unit to the other using any connection, top or bottom. Here we will use both bottom connections. Then you connect one unit to the display. Either one will do, and the system is mounted. This mounting process is the same for all of the D-series shaft systems. Now we are ready to start the display and choose a program. We will use Program 12, Easyturn. Both beams are now on, so it is a good time to adjust the beam into the center of the target. If you are using the beams to make a rough alignment of a long jack shaft, you would do this with the units in the 9 o'clock position as we have shown here in a close-up so you can see the procedure. All we are doing is putting the beam into the middle of the detector's range. You do this by turning the red beam adjustment wheels on the sides of the unit. Make sure that the target door is fully closed before adjusting the beam. The display is prompting you to input the basic measurement needed for shaft alignment. With the tape measure, you measure the distance between the measuring unit S2M, the distance from the S unit to the center of the coupling, the distance from the S unit to the front foot, foot 1, and the distance from the S unit to the back foot, foot 2. Now we input the information into the display. The first distance is S2M, so we key in 5.7 inches and press enter. We accept the halved distance between S2M at 2.8 inches. Now we input S to foot 1, which is 10.5 inches, to the back foot S to foot 2, which is 16.5. We are now in a position to take a shaft measurement, and we can start anywhere in the rotation. So let's start at 12 o'clock and press enter. Now we must move the measuring units a total of 20 degrees, which is indicated by the same mark next to the line. We just need to pass this mark and press enter in order to record the measurement. Next we record one more measurement, choosing whether to move the units back or in this case continue in the same direction. We now have a result, and if we want to go live in the horizontal plane, we simply move the measuring units to the 9 o'clock position. The feet on the screen go black, indicating that the machine is reading live time in the horizontal plane. If we turn the heads to the 12 o'clock position, it will now read live time in the vertical plane. After we make our corrections, we will try and remeasure. Let's take a full sweep because we are not restricted. We will start at 9 o'clock and record a measurement. Next, we record at 12 o'clock, and lastly, at 3 o'clock. Take your time. The goal is accuracy, not speed. The results are shown and they are very good. Let's check them against the tolerance chart by pressing button 4. Use the forward arrow to select an RPM. 1000 to 2000 is the most common RPM, so we accept this one. The results show that all the half couplings are black, indicating that we are in tolerance. Let's increase the RPM to 2000 to 3000. All of the coupling halves are still black, so we are still good. One more time, let's try 3000 to 4000. It looks like we have some work to do in the vertical plane, but with the Easyturn program, it will be easy.